Come back.
I did decide to come back.
Did you find that y equals mx plus b?
Okay,
Conversion.
I'll go ahead and find that in a minute.
No worries.
I'll
I
start
wrote
with
it down so we can do that offline.
Well, yeah, either way is fine. I mean, I think we can take a look at that anyway. But before that, welcome back everybody to day 3 of what's a microcontroller with Python and the Microbit. I'm Andy at Parallax, and will be speaking for part of this session, and we'll also be hearing from Nicole Litterer, who works on standards alignment and assessment materials for many of our series, including this one. And so she'll walk you through some of the teacher's guide, assessment, and standards stuff that she's currently working on. Today I did have some demos planned, but also ran into quite a variety of computer challenges today with Zoom and Zoom not cooperating, and now the Cyberscope isn't cooperating. So I'm pretty much out of luck on my demos. So we'll be skipping that. And we'll go to talking about some of the planned activities and projects, looking over how the teaching materials works, the cyber.org curriculum, and then Parallax kits. Last but not least, we'll have a discussion about simulators. I set up a couple of examples of using the different simulators we talked about on Monday. That's the Falstad simulator, and let's see here. And then the other one that I did the set up an example with. Sorry, I'm looking for the link to that. Okay, well, I can't find that anyway. Hopefully, by the time we get to the simulator discussion, I'll be ready to show you that two different takes that that we have on simulation, and try to decide what's going to best support the existing material. So first of all, in lieu of the demos, let's just do a quick review of the Servo homework. So we started with connecting the Servo, and it's a micro servo, and the tutorial starts off by pointing out the things like the mounting flange and the cable, the horn, a screw that can hold on the horn, the plug, and all that. But in your kit, it looks more like this. You get a bag that has the servo in it, but it has a variety of different shapes, and they're called horns that you can attach to the output shaft of the servo. And so this is a single horn, and then there's 2 and 4, and a round horn. So the 4 one, for example, is a star shape with essentially this appendage going out every 90 degrees around the horn. And so the servo turns to different positions. You attach things to it, and so you can use it for animatronics, for various things like M&M sorting, and they are used in model airplanes, boats, etc.
You know why, Andy, that of all the standards, why it seems like servos use brown versus black, when brown and orange can frequently seem so similar? You know, every other seeming servo or device or sensor, except for servos, follow that normal standard.
Yeah, I don't know why. I mean, the Parallax servos all do the black, red, white, black for ground, red for power, and white for signal. So this is a Vtec micro servo, and stock, it comes this way, and quite a few, as you pointed out, do. I don't know why they do it. I'm just guessing that there's an international standard somewhere, or a standard for another group of nations that is not your black for ground, red for power type thing. So this is a little tricky. The idea is that you push the horn onto the output shaft and then rotate it all the way to the right until you feel the stopper, then pull off the output shaft and then put it back on so that it's pointing roughly a little below horizontal to the right. So that's the way to get started with the servo. I want to do. I mean, it says so in the instructions, but it's something I want to emphasize because the examples later have it pointing to the right 0 degrees and pointing up 90 and to the left 180. How did this go as far as getting the circuit connected? How many of you felt like you were able to confidently move forward with this little zoomed in view here in the homework? Got one thumbs up.
I have one comment. The only issue I had was I had gotten the polarity wrong. I knew it was wired up because it got hot, or I felt a lot of heat, and I said, oh, double checked it. So it's probably a common error that you get red to blue and blue to red type of thing.
Okay, I think that may have happened to another teacher who also reported that her microbit stopped responding after that.
Well, it's still working.
Okay, yours is still working. So I think I'm going to have to put some great big warnings that say don't make a mistake on your polarity, or triple check your connections or something like that. So I take it then that this was followable, but mistakes can still happen that generate heat, which is a little scary. We're going to have to look at that and try to make sure that nobody cooks their microbit or battery pack. Yeah.
You had that one statement you just brought to mind, a statement you had further up where it talks about not commenting the sources. In other words, the battery with the regulated voltage.
Mhm.
And I think if that can maybe put in, maybe highlighted there, because
Okay.
I can see a student reading past that real quickly.
Yeah, so when this goes to the web, it goes in a red box with a little yellow triangle with an exclamation point in it.
Which one?
I'm
trying to move your screen. Never mind.
it,
I keep doing that. Further up, where you talk about the regulated voltages. No, that's the circuit. Somewhere further down, it talks about the common ground.
okay.
So that's all connected together. But then there's one little paragraph right there that says, you cannot connect. Well, basically, it's telling you can't connect the regulated 3.3 volts to the battery voltage. This one right, that's the one right there.
Yeah.
Is that it? That is why. No, that okay. Yeah, that one there, I think should be, however you do it, but something that causes a focus on it, because I can see someone just blowing right back, by that and not really paying attention to it, and that would have some bad consequences.
So anytime the person who publishes to the web sees that notation,
okay,
she puts it in a box that has a little yellow triangle with an exclamation point in it.
super.
So, okay.
Sorry,
good.
Sorry to take it off track.
No, actually it's right on track, because we had 2 teachers report that there were connection mistakes that resulted, one in the batteries getting hot and the microbit becoming unresponsive, and another in the microbit getting hot, but he caught it and disconnected stuff. And so we need to try to figure out what the possible mistakes are, and then document it in such a way that the students can't do it. Possibly update this board to make it impossible, but I don't think. Yeah, I don't know. We'll have to see. but no, it's very important information. So thank you.
Okay, so here's another comment that I would have. With this particular set that you guys had sent me, there's no on and off switch on the battery pack. The problem that I've been having is the connector, the little itty bitty teeny weeny whitey connector that goes into your cyber.org edge connector, or if it went directly into the Microbit. It's a very tight connection. And I can see that some of the students are going to have to be plugging and unplugging, and that connector that's on that board is going to just get ripped out real quick.
Yeah, now I had mentioned that there's a third-party get it from Amazon connector that he found that has a little switch built right into it.
But I would suggest cutting the ear. What I did is I cut the ears off of it. You know, there's the two little bumps on the side, because it's got enough force to hold in there. I think with struggling with it, eventually you're going to damage the circuit board, because I mean, you really have to pull on that, Brett. At least from what I saw.
I've had a couple of microbits with this connector break, and so with the kits, we actually cut the red wire and then put in just a toggle switch and taught the kids soldering for that. So they did a small soldering connection, and that way they could stay connected in the little Harbor Freight tote kit, whatever we buy to hold it up, and then it reduces the wear and tear on it a lot.
Right. But
Yeah,
what
that's a
I'm
cool
thinking,
activity.
Andy, is that you might want to, in a later version of the adapter, have the female connector for the battery pack on a wire even, and instead of having the connector on the board, have a switch right there.
Okay.
Yeah, those connectors are really made to make connections once and be left alone. Like when you're wiring up a computer, they're really not made to be pulled and plugged in a lot.
Yeah, now I want to emphasize that this is the one that comes with the Microbit Go bundle. It's not part of the actual it's part of the Go bundle, and it's what we had to work with.
It's Microbit, but I'm looking to see if I can find that wire to board with an on-off switch.
Mhm.
Yeah, Ed sent me a link to it. I can share that out with you. Let me make a note.
Not to beat the dead horse too much, but it's a well-documented issue among Microbit users, and I don't see it changing because it's the nature of the JST style connector. But we could, though, consider a power switch on the edge adapter in the future.
And that's basically what I was referring
Yeah.
to, not other people's stuff, but your stuff, since this is the second iteration, I guess, or so of the adapter. And it's really important that in this particular servo setup, you actually were being told to plug and unplug when you're not using to conserve the battery power. And again, I can see the students just ripping it out and
Yeah.
wires going all over the place.
And that switch is worth an extra $1 or $2 to all of you, right?
But what about having a jack like you do, like the Bobot has, and then you can use a AA battery instead of the AAA? Because I just went out and invested in that charger, Andy, that we talked about, and I like it.
Okay.
But I mean, you know, if it was like the problem is finding stuff. I searched all over. I mean, I didn't want to go to China to buy it, but no one sells it. You don't have it. No one else has it. You cannot buy that. You cannot buy that battery pack separately.
And you're talking about the battery pack that has a switch built onto it.
I'm talking about either one. I mean, I didn't start to buy the one with the switch. I started just to buy those because I just bought the boards. I didn't buy the complete package.
Yeah, okay.
And then that's what made me go in that direction. I called up and spoke to one of the people on the line at Parallax for orders. And I said, is it, just not a number? And, she says, no, we don't sell them. So
Yeah.
I think either way, someone's going to have to figure out how to have something, because these things, they keep even pulling on the wires, what's going to happen.
Yep.
And you do have those extra solder holes for the bus that are on the adapter. Right, that's over there and on the top there. So there's plenty of place that you can have a dongle of some sort that could go into anything else. The other thing
Yeah.
I would point out is that in real life, I've gone away from using batteries, and we use either the battery adapters, which are usually like the 5-volt phone adapters, and if necessary, we put a voltage regulator on the other end to make it
Let me
easier.
pose a question to you then. Let's say that we instead had a barrel jack that was plugged in this area up here. And then you could plug in a separate battery pack and unplug it fairly easily. If that ended up changing the price of the kit by, say, $5 or $10, so it goes from $90 to $100, is that something that would make it more favorable to you, or
Are you going to have a voltage regulator that lets you put on whether it's AA, AAA, 9-volt, whatever?
Yeah, well, my initial thinking was unregulated, because there's a regulator, or there could be a regulator on here, but I think we're currently using it unregulated. I mean, this board could, in theory, expand so it covers this whole whole area, and then has a nice barrel jack and a switch and stuff like that. But it might cost $5 or $10 more retail. What do you think of that, of going from, say, a $90 kit to a $100 kit?
It's almost cheaper to supply that battery case holder with a switch.
It is.
And your real estate would look really odd having, the microbit fitting into something that was then substantially 50% wider.
Yeah, it's not cosmetically great. I'm basically just using the I'm doing a food for thought discussion, and basically just trying to get as many ideas from y'all as possible. And so,
Andy, I have a case that has the on and off switch. It came from a company here in Alabama, Fiera Labs. I'm not sure if you're familiar with him.
I'm not.
And I did a workshop through Infosys, and that company did a workshop with what was it called? Not a code bot, but a little robot like this. And they had some microbits as well.
Okay.
And with the microbits that they gave us, it came with the case with the on and off switch.
Okay.
So if you want me to find out where they get their cases from, I can, because they're here in Alabama.
Well, that would be fine. Sure. I mean, that would be great if we could get a link to the cases. I think that Ed also sent me a link to some cases that he was able to purchase, and we have purchasers that can also look for and find the most economical cases. So if you're, if you think it would be better just to get like a battery pack with a switch on it, and leave the JST connector connected full time, that's also an option. What do you guys think of that?
Yeah, I'm seeing these cases on Amazon for like 90-something cents a piece.
Yeah.
Okay.
That's what I paid. This is, I don't know if you can see the switch, where the switch is, but that's what it looks like.
Yeah.
And yeah, they were not, I bought 10 of them for $10, but came by way of China. Oh, well.
Yeah, so that's gonna, it's,
I'd rather get it from you people.
yeah, and we'd rather supply it if that's what's needed. So if everybody's happy with like this overall form factor, and and we all just think that the JST connector is okay as long as we have a switch on here to turn the power on and off, then that makes it a lot easier on us in terms of a way to provide you with that solution.
You can even double the price and I'd still be happy.
All right, well, I'm going to give you a minimum buy quantity then too. That's great to hear though. Thank you. All right, so so we will look into a battery holder with a switch, and I have that in my notes. So then how did this, for those of you who were able to get your servo running, can I get thumbs up? How many got their servo moving? Okay, very good. Good job, everyone. And so, did any of you have to back off from either 128 downward or go up from 26 upward to get the full range of different positions? I know Ed did. Okay, so everybody else had a decent demo with this, of it pointing all the way to the left and then all the way to the right eventually. Okay, I'm getting head nods. So yeah, we do, since we had one report, I'm definitely concerned that, you know, once this gets out into the world, that we'll have more than just one report. I think that there are process variations within the digital servo, so that unfortunately, you know, 26 is sometimes really 25 to the digital servo. The oscillator on the Microbit is pretty precise in comparison. I think what's happening is the oscillator or resonator in the digital servo that it's using for its clock to compare with these signals that the Microbit is sending is you know, more prone to temperature and process variation. And so basically, I'm probably going to have to do this to where we don't go all the way to 0 and all the way to 180 degrees. I thought I could switch to that since we have now a digital servo, but it looks like there's still there's still enough variations that I'll have to go back to the old approach I used with the analog servos, which was to show them maybe 30, 90, and 150, for example, instead of 180, 0, etc. All right, so so this was the current positions. It should have turned the armature to. And for discussion, we talk about, okay, here's the different statements that resulted in each of those positions. And then I made this little thing that actually shows the pulses. So in the previous activity, we looked at pulses as LED light on-offs. And so this is an extension of the LED light on-off signals. It's just that the timing is much faster. And that's one of the reasons we introduced the period, which in this signal is 20 milliseconds. And then there's a duty cycle associated to it. But in servos, you really think about, you know, how long does the LED light stay on, whether that's half a millisecond, 1 millisecond, 1.5 milliseconds, or 2.5 milliseconds. And each one of those signals results in an angle that is further to the clockwise. As the signal stays on for longer, it goes further to the clockwise with the light. And I'm probably going to send you a follow-up pre-recorded video because I'm having some technical challenges today with my setup. And so I'm not able to show you this, but I want you to know that the lessons will support measuring this with the Cyberscope. It's really cool. What the Cyberscope, well, I can show you the code in a while if time permits. Now I'll just tell you, the Cyberscope has a ability to measure high pulses down to microseconds, and likewise with low pulses. So what the Cyberscope or what the microbit script does is it measures this high time and then this low time. And then the script takes that and generates a bunch of samples to send to the cyberscope so that you can actually see in real time, depending on what angle you're at, what these actual high-low pulses look like. It's very cool. And you can add in, say, a potentiometer with that, and then see the potentiometer voltage as you're turning it, and it's causing the servo to go to different positions. All right. So let's see. Somebody said that I had a mistake in my calculations. I think that was Alan.
Yeah.
Do you remember where that was? Must have been
It
somewhere in
was
this.
y equals mx plus b. It was on the code where we are changing and using terminal input to convert degrees as opposed to typing in the pulse range. So in that one there, yeah, so I think it's right in there, but basically, it might have been in your, scroll down a little bit.
I think that's the end of
I mean,
it.
that's the code, but you were giving an example right there. So, yep.
Okay.
So go down a little bit into
so-
the text.
Oh, it's in the text. It's not in the, okay.
Yeah, so right there, unless my calculator is weird, which is possible, if you take your 0.5689, multiply it by 30 following PEMDAS, okay, and then you add your 25.6, you get 42.667.
Oh, instead of 767,
Yeah,
like that?
so
And it's 42.667?
yes,
Okay. And then, so this should be 43.
yeah.
Okay. Oh, thank you. That's wonderful.
Wait.
Nope.
But then the
Okay.
20, I think you need to add the 16.167 plus the 25.6. Yeah.
Yes. Plus 25.6.
42.667. Yeah, so you were right.
But
And
this,
then,
the 16.167 plus 25.6 is
Ooh,
not that.
okay, hold
That's what
on.
I'm
So I
saying. So
gotta-
there's a
yeah.
mistake with the 16.1, either I didn't do the math, but I
It
could
should
tell
be
you that.
17.067.
689 times 30.
That's 17.0, yeah.
There it is.
There.
Yeah.
All right, we're good.
Good.
Yeah, this is normally the kind of stuff that either Nicole or Stephanie catches. You have seen this document before they actually got to see it, since it's still since I'm still building this one. So I haven't actually, done the proofing that I would normally do before passing it to them, and then they proof it. And so when it gets to the web, usually those kind of things end up being caught and fixed.
If you go back up to where you just were.
Okay.
A moment. Stop. No, up, no, the other up. The other way, down, stop. The cycle is now 43.
Yeah.
So you got to change that too.
Yeah, you'll have to change the example where it says if the duty cycle is 42, so it's 43, what's the resulting angle?
Aha, okay.
That math will have to reflect accordingly.
Got it.
But the 42 should be a 43.
Yes, so I added okay, I'll expand on this. Change 42 to 43. There, everybody happy? So I've got a note to self to fix
Change,
that.
yeah, change the second line of equals, so that's gonna be equals 17.067 divided by 0.5689.
Yes, I will do that. I'm not going to do it now.
Okay, just make note that math means.
Yeah,
We need closure, Andy.
I'm sorry, what? causing everybody anxiety disorders. All right, then.
You made us
Um,
wake up and do algebra.
I'm glad it's not calculus, Andy.
Well, you know, did you ever notice in calculus that it wasn't usually the calculus that got you on exams, but like that silly little, 2 + 3 is 7 mistake you made? Yeah, anyway, I'm
Flowers
seeing
for
some nods.
algebra.
Yeah, it was usually in the algebra or just the simple arithmetic. All right. Anyway, I really have to leave that be for now. I'm sorry, guys. Now, is there anybody who's interested in hearing about when one of these is ready for review? Because I can set certain people up to go through a Google Doc and add comments. So, okay, I see a few hands up now. Let's see, that was Ed, Charles, and Alan on page 1. If you guys just want to say sign me up in the chat, sign me up to be a reviewer, what we can do is I can send out an APB to you all who want to be reviewers to go through it and point out things to your heart's content. So thank you for signing up, and we'll look over the chat and make sure we extract that data and I put you on a mailing list. All right, so coming back to, I think one thing I'd like to try is a little example I wrote called accelerometer servo points down. Oh, that's right. I can't drag it from Drive into the I'll go ahead and chat in the this is a fun one for those of you who've got the servo going. I am currently looking for the chat button, and it moved because I updated Zoom. There we go. So that is that's a script you can load into your
It didn't
load it.
come across.
Okay, that may be because I've chatted it to Ken directly by accident. There we go.
That worked.
Okay.
Thank you.
So this is a kind of a fun one to try because it will, and I'll show you in just a minute. I'm going to stop my share. Let's see, I'm going to flash it first, make sure it works, and stop my share. Okay, disconnect, stop share. Hello, everybody. Yeah, so it's kind of fun because this is an example of using what's built into the Microbit. So first of all, the way to hold the board for this example is with the USB cable pointing up. And do you see how the there's a little arrow or a little clock hand that is always pointing to the downward direction? Okay, so if you put the servo next to it, now as I rotate the board, the servo also continues to point down. So that's one of the activities where I mentioned that there were some Easter eggs in that Servo document that we were looking at. And this is one of those. I basically I pasted in a number of code examples. And so this is one that is going to allow students to have some fun and play. And now that we've gotten through some of the main activities where we're building circuits, it's really time to start using kind of mixing and matching some of the built-in features of the microbit along with the circuits you've built. And that should make it a lot of fun, I think, for the students. Okay.
Andy, is there a way to get the push buttons to turn the servo?
I believe so. I think that's another one of the Easter eggs. Let me check for button controlled servo.
I would really like to use those as remote controls for the.
Okay, so if you want to do button servo control, I'm just about to paste the code into the chat. Okay.
I have to tell you, as an educator, I really appreciate that we've got this basic board built, and that you've taken and put a lot of consideration into saying, okay, we can move and cycle through our LEDs, and then now we can just throw the servo on and do some other code, as opposed to having them to rebuild and constantly change. So it's really nice.
Oh, thank you for mentioning that. That came about because of the fact that when I was doing the original basic stamp What's a Microcontroller courses, even though I'd call it out, I'd say, okay, everybody leave that circuit you just built on your board. We're moving into a new chapter. That circuit won't be showing until later because we just want you to focus on the circuit you're building. And invariably, several of the teacher attendees would, tear down the circuit they built and then be disappointed that they had to rebuild it, 30 minutes later. So yeah, so what we do here is we start with the setup from previous activities. And so folks who are going through it sequentially get to skip this. And then folks who are not get to build it. And then there's all the information about where you can go to build and test the different parts, depending on how much of this you need to rebuild. Then when we're doing, sorry about the scrolling here. I'm looking for okay. So when we're doing a new circuit, notice how
we don't see your screen. Sorry.
Oh, I'm sorry. Let's see here. Okay, share screen. Oh, darn it.
This just makes it really nice. Like I could see advanced students, being able to just go in and say, great, hey, go build 12 of these for me and have them ready. So if the kid screws up, you can literally just hand a new set right there, ready to go. I just appreciate it.
Yeah, good. I'm really glad. And so this is page 13. So I'm going to jump back to what I was doing here. Okay, so we start with a page that has the setup from previous activities. And so it shows it and it says, hey, if you've been following along sequentially and you have the previous one built, just skip the rest of this page. And then for anybody who is part way or no way there, we've got the full setup from all the previous activities, and then links on how to get there and how to test your circuits and stuff like that. So that when you get to here, everybody is hopefully on the same page and they have all the previous circuits still built. And then that way, sure, in the first activity, we're only focusing on the circuit that we're building, but as a cue, we've got the translucent versions of the circuit that they've built up to this point to let them know, yeah, it's still going to be there. And we're just focusing on this part right now. So that was the compromise that I did was, all right, instead of like completely removing this, we're just going to make them translucent. And then that way we can still focus on the part that we're building, but the rest of it's ready when it's needed. Now, did anybody get to try the, I pasted through the push button code. Did you get to try that yet?
Yeah,
I did.
I tried it. Yeah, it
Holy
worked.
smokes.
Yeah,
Okay.
it worked.
I know this is completely off subject. Here on our ranch, we've got corn that's 14 feet tall. And my son just went and picked an ear that is almost 18 inches long. Sorry.
That is a rather
is
large
nice.
ear of corn. Are you holding it up?
Yeah. I mean, here are my two hands. I've got big hands and they're still,
That's gigantic.
You know,
Is
we're
that yellow
10 minutes
corn?
from-
yeah.
10 minutes from Valparaiso, and we would be jealous of that. We would be jealous of that. That's
Now
where
that's-
Orville Redenbacher's from.
Ah,
Okay.
sorry.
No, not at all. So I kind of
Move
want to
over.
run that push button code too. I'm trying to get back to the chat. Or let's see here. Here's push button servo control in the script.
Alexander? No. Ja, that's right. No.
All right, so if we paste this in and load it. Yeah, the more parts that we add, the more mix and match opportunities we've got. And so, let's see here, stop share.
Can you explain something in that code?
One moment, yeah. So I just want to demo it for folks who don't have their boards connected. Okay, how's this look? Oh, that's completely upside down, isn't it?
Depends on which way you're standing.
All right.
That was my, well, that was another question.
Okay. So here we are with the servo. And with this script running, now I'll press the lower button. So the lower button causes it to go counterclockwise, and the upper button causes it to go clockwise. So that is an example of, I'm sorry, I forget who requested it, but that is an example that is in the main text. We do save some for solving it as you go. We need to be able to assign stuff to students. All right, so what was the next question?
The command, when you go to pin 9, which I'm wondering if it's Microbit, but line 6, line 7, where you're going in and setting your pull, and it's a no pull statement. So you've got pin 9 dot no pull, and I'm curious.
Okay, so the document you shared on, I think it was Monday, was about the
edge connectors, yeah.
Yeah, and so there's a lot of special stuff going on. For example, anytime you have a circuit connected to one of these things that says LED column, so that's I don't know what, so that's P3, P7, etc., P6. So anytime you try to use one of those externally, you want to turn off the display.
Oh, got it.
Okay, then of course we've got our analog ins. And let's see what else. Oh yes, now there's a few things that don't show on here, but that show further down. Like if we go and look at pin 9. Okay, so P9 is, boy, it looks like it's connected to the push button. Is that right? No. Oh, it defaults to an output, sorry. So this is the default, whether it starts out as input or output. But like let's, for example, look at P11. P11 has an internal 12 kilo ohm pull down resistor that is set by default. And so if I'm going to use P11 and I don't want this resistor to be part of the party, I use the statement that you asked about, which is pin 9.setPull, pin 9.noPull. And so what that does is it just takes any of the, so display off is what turns off the display so that pins, so that circuits connected to any of the display pins are not interfered with by the display's operation. And then removing any internal pull up or pull down resistors. I'm just doing this now by habit when working with external circuits. And so that's where that comes from. Okay, what do we have next?
If you
Okay, so-
didn't do that, would you just wind up with resistors in series?
It just depends on what direction it's pulling. So some of these are going to have internal pull ups. Most of them have internal pull downs, but like, let's say that you want to use a push button with a pull up resistor. Well, if you put a 10K pulling it up and then you've got a 12K pulling it down, it's kind of stuck in the middle as far as the voltage that it's going to read, and your push button ends up not working.
Got it.
And so that's the main reason. And that's where I stumbled across it most recently is I did an activity where the student changes the push button from a push button with a pull down resistor to a push button with a pull up resistor. And I couldn't read the push button anymore. And it was for lack of these kind of statements. And I think it was P6 that has that I made the pull up resistor. Okay, so I'm going to come back around to planned activities and projects. I just want to talk quickly about teaching materials. And so this is, so we had all you guys make sure you could log in. So if we were to go to learn.parallax.com, I'll do that on an incognito window so I can log in without long story. Basically, I don't want to end up logging in as somebody who publishes to the site. I want to log in as like you as a teacher. And so, if you don't want to have to remember the web address to log in, generally you can go to any one, and I'm going to pick out Cyberbot Resources as an example. And most of the teacher materials, whatever possible, we leave publicly available. So here's the teaching guide, slide material, etc., standards matrix. And all of these things are not answers to students' questions. But if you want to get to the assessment materials that you can use, you'll want to go to the login page and then log in. Maybe it is at ATT. I don't remember now. Let's see here. Oh, that's not going to go well. Sorry, guys.
Why is login sort of hidden?
I don't know. Ken, do you have any knowledge of why it was so, why it's not more prominent?
I mean, you just think, okay, you get there, but if you're not logged in, then you've got to know to go to user/login as opposed to, I don't know, a button.
I don't know, Andy, it's bothered me too. We got to fix that.
Okay, yeah, it's bothered me as
So-
well, and it clearly is bothering some of our attendees. So we can do a teacher login that's more prominent.
We've got like, are you an educator? Let's chat. How about, are you an educator? Log in.
Yeah, Yeah, exactly. I mean, there have been quite a number of sites I've been to where, there's just an educator login. I mean, basically at most school sites seem to have that pretty prominent, like right on the homepage, the teachers can log in. And so now that I've logged in and I go back to Cyberbot Resources, I have access to the assessment material. Let me go back to the beginning. So learn.parallax.com. Currently, you go to educators and then your subject of interest. And then previously, this was a thing saying, we're not showing you anything here, you have to log in. But now this is, and I followed the login link, it was in this box, but now you can get to the assessment material and you have the full zip, and then you have individual lessons that you can go to. So I wanted to point that out. So basically we're going to do the same thing for the What's a Microcontroller as that gets flowed to the Learn site. Going back up a level, Nicole is going to talk with you about some of the work she's doing, because she's doing a little bit more in the teacher's guide realm than we've done previously. And I'm going to leave that to her. But just to point out that we do have teaching guides, things like slides. It really depends on which product you're in. Just about every product has a standards matrix and then some kind of scope and sequence document. So these are all, just know that this same type of thing is coming for the What's a Microcontroller kit. And let's see here. Hey, Nicole, are you fairly ready to talk about some of the work that you're doing?
I am, yeah, whenever you're ready.
Okay, I need just a minute to pass the screen control over to you. But first, let's introduce Nicole. Nicole has been working with Parallax since 2015. And so she's done assessment materials for us for the Scribbler, the Activity Bot, the BOE Shield Bot, and most recently the Cyberbot. She currently works as an instructional coach, supporting classroom teachers through practices such as instructional delivery, lesson design, standards alignment, and assessment. And she's an Iowa native who has her master's in teaching and learning and educational leadership, and is currently also in a doctoral program at the University of Iowa studying continuous improvement models. We have all greatly benefited, Nicole, from from the work you've done, both at Parallax, since we get to give teachers something that's of higher quality, and of course the teachers have been using it too, and are the grateful recipients of that. So thank you so much for everything that you've done and continue to do. And I'll go ahead and pass the screen to you.
Bravo, Nicole.
Thanks, Mark. Thanks, Andy, for the introduction. I do what I can. So yeah, my background is in education, not really electronics. So I've been learning along the way as the last 6 years working with Parallax, and have learned a lot, and super excited for the opportunity. Frankly, I met Ken a long time ago in a class, an on-site class, a lot like this one. So yeah, anyway, I'm just going to show you what I have created so far for this. And if you have any suggestions or comments, please let me know. So I'm going to share my screen. Okay. I'm going to work with the electrical measurement, and I'll just quickly show you what is in the teacher's guide. So I've just started with the standards, so they are not in any way completed. So if you have suggestions or different standards you would like addressed, please let me know. But I started with the K-12 computer science framework, and I just pulled out standards that are related to what's in the tutorial. They potentially would require a little bit of expanding upon, but they're definitely related and tie into whatever the standard is. I heard someone mention middle school, that they are using this material in middle school, so I did pull in middle school and high school. I'm also using, so that's the high school, the California K-12 computer science standards. Those will be referenced in here. And then the California Career Technical Education Model Curriculum Standards. And I am working with, yeah, the engineering, in that engineering and architectural standard pathway. So
What
focusing.
about ICT as well? The
Yes, sir.
information, computer technology. I mean,
Okay. ICTE, I sure can.
yeah, it's, I have my certs in 3 or 4 of these, but sometimes I think Andy was saying it kind of yesterday that there's hardware and there's software. And so it does, it's like, gosh, the idea that the two talk is heretic, but
Yeah, absolutely. Whatever you're using that you guys use, we want to have in here. So yeah, for sure. Let me know if there's something different. Or if you're like, no, we don't use that at all. Don't bother with that. Absolutely there too. Okay, so these are just listed. Okay, so further on in the teacher's guide, I just include a brief summary of what is in the tutorial, what you'll find, and then a little bit of background information if there's something specific that a teacher might, have some questions about along the way. So I try to include a little information about that. And then just some basic things about teaching the tutorial, things you might want to have done prior to, like, think about an organizational system, how you want to have your materials ready for kids. There is also some things about, I just added some of these things this morning. So some of the things that you guys have mentioned, like make sure you unplug the USB, just a few of those reminders to make sure that kids do that. So the teacher hears it several times, so they remind the kids to do that. There's a little bit of information on differentiation if you have kids in a variety of levels. So just some suggestions, ways you might be able to support all of your kids, whether they are on the lower end or on the higher end. Some extensions. Again, this one is still being built, so I'll continue to add more information. The activity outcomes are in here. You'll see those at the beginning of each activity. So they're in the teacher's guide so that you know what those are ahead of time. Really important that kids know what they want to, what they need to leave the tutorial with. So make sure you look at these. And then at the end of each activity, there's a student self-check for them to self-reflect. So more or less the outcomes are repeated. And then there's a few questions that the student should ask themselves. Can I, for example, this one, do I understand why the voltage is different? Am I able to apply that KVL formula? So just some things that they want to reflect on. If they can't do it, they probably should go back into the tutorial and look at it a little closer. So anyway, there's one of those for each activity. And then there is a vocabulary, and it's broken down by activity that they'll run into. I only have it the first time that word is introduced. So if circuit is in multiple tutorials, it'll just show up in the vocabulary list for the first one. So that is in there. And then, yeah, just the references. So I'm also creating a scope and sequence for this one. And a second to load. They're linked on this just so that I could show them to you quickly. They won't be linked in the teacher's guide. You'll want to go back to that learn.parallax.com to find them. So it'll have the concepts, coding, the standards in just one quick guide so you can see what's where in each unit, what's covered, what standards are covered, things like that in each unit. And sorry, my internet is a little bit slow. Okay, so at the end of the lessons that or the activities Andy has been showing you, you've seen some questions, exercises, and projects. So we've pulled, some of them are posted, and then some of them are in a separate document. So you'll be able to access these if you want to do some formative assessments, quizzes. There's questions here that are already prepared for you. So you'll see the questions. Those are more vocabulary type questions or things that are facts that are sprinkled throughout the activities. So those would be in the question section. And then down a little further, whoops, I went too far. You'll see exercises, these would be things that would have to do with more of the coding, or they need to do some calculations. Those will be in exercises. And then, whoops, again, I went too far. And then projects. So these would maybe be things that they're going to build, some extensions on things that they did in the activities or the tutorials. And then down below, if you just keep scrolling, you'll see the answers to all of them. They're broken apart. I tried to, this one is not done yet, but I tried to separate them by page so that you could just print off a page and then the answers are on the next page. So you don't have to go in and monkey with trying to cut those apart. I know that's kind of a pain when you're trying to stand at the printer or copy machine. And then the last thing here. So these are more formalized assessments or worksheets that you could use. They're formatted a little bit more in that way. They're set up in the same way, all of them. They always start with a matching activity. And then there is always some multiple choice. Let that finish loading. There's always a little true false section, and then there's some short answer. And then again, if you scroll down to the bottom, the answers are always provided there. And then there's a little rubric to use to grade the short answer questions.
This is Alan. I have a question as I think about this from, getting students to want to go through this. It's not that I drink the Google Kool-Aid, but since we're kind of using it, have you ever thought about making these as the assessments as Google Forms, and then students could go through and we could actually have all of that data collected, analyzed, look at it to see, where am I missing things? If nobody even understood what a circuit is, obviously I was having a bad day.
Right, you could do a quick check. We have before, Ken, I honestly can't remember which robot it was for. We have done it before. That would be up to.
We did, yeah. So there's a workflow challenge here, which is first we need Andy's work, then Nicole's work, and then we need it all to settle. And then we could do that. But Nicole's always been so busy doing exactly what she's showing right now that there's a lot here to round this whole program out for you that we haven't had time, but we're open to that. It's another layer of things to maintain for us, but if any of you take it on, maybe we could just share your work back to the rest of the world.
Yeah, it's fairly easy to copy and paste and put a quick answer in. If it's the exercises or those questions, you need with those Google Forms, you need, that hard answer where they can do just a multiple choice. But it's something certainly, that can be done once the assessment's written.
I'm not trying to look a gift horse in the mouth. You guys do phenomenal work. So please, that's not like a dig in any way. It's amazing the detail.
Well, we need to hear this because you fuel us, and it's a cycle that we want to maintain. And actually, a lot of our support comes from cyber.org for this particular project that Andy and Nicole are showing. So thank them too, and let them know it's useful. In fact, I'll just drop their director's email into the chat if you want to take a moment and thank them.
Yeah, because if it weren't for cyber.org, for example, I don't think you would see the cyberscope. I don't think that would have become a thing. And they're also they helped ensure that we could create some of the animated explanation animations that we've gone through during this class. And so those are two things that are unique, and it came from their support in the project.
And it looks like some folks have asked about the standards. Again, like Ken said, I follow Andy's work. So as soon as those are, as soon as I get them, then I start to work with the questions and the assessments and the standards. I guess a question I have is, what's most important to come first? Is it the standards, or, what do you guys want your hands on first?
This is being recorded, so I don't want to answer that.
I've got to write this up, so I would just like to go through an order of procedures. For instance, first we're going to power the Cyberbot. Now we're going to program the Cyberbot. You know, that's just simple, but yeah, procedures and steps so that I can break it into units, so that I can break it into semesters and, you know, put it through for approval.
So seeing that scope and sequence. So
Yeah,
you
I think about what it is that I really want them to learn, and then frequently I'll go back and look at the standards, because trying to find the standards, you just find that they're all over the place very frequently. Sort of like you're saying, you don't want to add for vocabulary circuits every time you use the word circuits in a lesson. Otherwise, every page is going to be incredibly lengthy. Like we've already learned that when you get into a lot of these, when you start looking at standards, I find that there's so many that just overlap. And you're talking about using mathematics and solving real world equations. And so that could be measuring a battery, or just going and getting it to turn on in Cyberscope or in every other place. So my focus as an educator is typically where I want to take them. And then I'll go back and kind of plug those in. In working with something like this, there's never been a shortage of, oh, are you following any standards? It's like, yeah, I don't think my standards list should be longer than my actual instructions and thing itself. So that's the way I approach it. Maybe it's wrong, but
we all have our method, Alan, that,
yeah.
that works for us. So okay.
Perhaps I'm sorry, perhaps a glossary add-on that had all the terms that you've defined.
Most of it's okay.
You could just pop over.
I think that first really, I think I'm gonna have to do my own
In one document.
series and parallel circuit.
That's easy enough to do. I can just copy and paste them into one document. Okay. That's all I had. So, oh, sorry, Edward, go ahead.
No, it's Charles. And
Oh,
that would
sorry.
It's okay. That would also work as a good study guide for the students.
Right. Absolutely.
Okay, well, thank you everybody for your feedback, and thank you so much, Nicole, for joining us today and for showing us what you are working on and collecting the teachers' feedback.
So Nicole, I want to thank you personally for all the work you've done for us for 6 years. You've been so methodical, consistent, professional, and you've learned so much, and you provided a whole wraparound experience for the teachers, and many of them write messages saying how much they appreciate it. So thank you.
Thanks, Ken. Yeah, it's my pleasure. It's been a lot of fun. So I'm happy to have the experience. Thanks.
Okay, so next up is, let's see here. Share screen. So are you folks still seeing an ongoing thumbnail of Nicole in your in the shared screen?
Nope, spotlight's back to you and your screen sharing.
Okay, very good. Thank you. All righty, so looking at the remainder of Friday. Okay, so we are here with, or we just finished the teacher's guide, and so are now going to take a look at the cyber.org page. Basically, I just want to say at this point that if you go to cyber.org, they have a nice login page right up front, unlike learn.parallax.com. And when you log in, you get access to a very wide variety of curriculum options for devices such as the Parallax Cyberbot, the BOE Shield Bot. I'll show you some of these products on the. So this is in addition to our own curriculum on that. Cyber.org has a separate set of curriculum you can use it exclusively, mix and match. It basically all works. And so just a quick show and tell about the Cyberbot. How many of you are already using the Cyberbot? Any thumbs up on Cyberbot? 1, 2 on page 1. Wow. Okay, so not as many as I expected. All right, so here is the Cyberbot.
COVID kind of put a damper in robotics.
Yeah.
saying.
Yeah, I noticed I got a lot of I got a number of tech support inquiries from mixed classrooms where some of the students were doing it at home and then others were doing it in class. You know, they kind of had a half and half mix. And that was quite the management thing with having the students pick up their Cyberbot kits. So here is the Cyberbot, and it also uses the Microbit. And it also is programmed in Python, and so it's another take on electronics with as opposed to a product design / inventing emphasis. This has the robotics emphasis, and you're still using the same Python programming system. We also have the Arduino version, which is the Shield bot.
I've got a full classroom set of that.
How do you like it?
Just to, sorry, and just to shout out to what cyber.org does. They usually have every couple of months they have a technology grant program. You can sign up, and I'm getting 10 of the Raspberry Pi units. So it's basically a classroom set of robots with the Raspberry Pi microcontroller. And one of my colleagues is getting site licenses for their cyber range. So definitely, if you take advantage of that, it's nice to get it. It's $2,000 worth of stuff or whatever it is. It's a good deal.
I'll echo that. I've gotten the cyber.org grant for classroom set of the Microbit bundles. That's how kind of we got started with this. But to go back to your question, Andy, we really liked the Shield bot with Arduino because we were able to get one for every student during socially distanced teaching. And we got nice cases for them, allowed the students to take them home on their off weeks, and they were able to still work at home. I think the only drawback was a couple of the students who had Chromebooks had a hard time uploading code. They kept on having to make burner email accounts to use the free Arduino Chromebook extension because you have to pay for it after like 45 days.
Quick comment on that. So
Yeah, me
EDU
too.
Code Vendor, you can get a free license from Parallax yearly. So just send an email to learn@parallax.com and we'll give you one. We're the only people that do that.
I will make a note of that. And my students were just making new email addresses.
You don't have to do
45 more
that.
days.
No.
A free license for the Arduino.cc.
This is not Arduino.cc. It's called Code Bender, and it's a very, very nice system. We purchase site licenses and then redistribute them on an annual basis. Ken, you can correct me if I say anything wrong here. And that is really important. We wanted to make sure that Chromebooks were equally supported along with Macs and PCs. And so the Code Bender software, let me see if I can bring up Code Bender here.
You could skip it, Andy. I just pasted it in the chat.
Okay.
So yeah, people can go look at it. It's COPA FERPA compliant, no logins, no credit card required from teacher. Just get our key, plug it in, and get going.
And what about for file saving? Are files saved in their downloads on their Chromebook?
Yes.
Yes.
That's nice.
But how's my IT guy gonna screw that up? I mean,
He's not, your IT guy won't be needed. Also,
thank
one,
God.
one more thing, I posted a link to the technology grant because it's hard to find in the chat as well.
Also, I am inside, I logged into cyber.org. And so, for example, if we look at cyber literacy 2, when you go in there, notice that they offer you the BoBot, the ShieldBot, and the Cyberbot. And so their full curriculum is available to you, assuming you sign up with them. Now, to get signed up with them, the important thing is that when you go to cyber.org, if you don't already have a login, there's a sign up link. And when you follow the sign up link, the main thing is that you have to be a teacher in the US. So there's a national security funding to cyber.org. And so they want to ensure that the beneficiaries of their curricula are United States teachers. Is there anything anybody else wants to add about cyber.org? Okay, I'll just say one more thing is that notice that I just went into cyber literacy 2 and that there's a very significant number of courses that they have available here once you're signed in as a teacher. So here's the entire list. And so I strongly recommend that you do that. We've already signed all of you up, or at some point either you already signed up for learn.parallax.com or we signed you up on Wednesday. So you're already in there, and this is another one to add to your bucket of resources. Okay.
Excuse me, Andy. So this is for teachers, but do students get an account, or how do the students get the account if they want to do some of the activities?
Okay, so the teachers get an account for access to the curriculum. Then they download and deploy elements to their students. So for example, if we're back in cyber literacy, let's say we're using the Cyberbot. And so here are the master, this is all teacher, well, it's teacher material, but notice that you've got some notes and then the student worksheets. Well, this is a worksheet that you're going to download and then distribute to them.
Okay, so it's not an online course for the students.
No, it is not.
The Canvas aspect
Wow.
extends mostly to the teachers here.
Oh, and that's the security reason, or?
Imagine so, yeah. I think they're not operating at district level, but more at teacher level.
Yeah, and the other thing is that there are so many different districts that already have a preferred management system for their content management system for their students. And so they can't necessarily fit every one of those. And so it's up to the teacher to, get the student worksheets and then put them on their content management system.
Okay.
All righty. Okay, so next up was the simulator examples. So I wanted to finish our discussion that started on Monday. Actually, no, I should finish the www.parallax.com. So this is a site that you can go to to basically see those robots that I was talking about. And I can also send you links, but for example, the Shield bot for Arduino is an example that if you search for it, you will get all of our kits that are related to the Shield bot. And then if you go to learn.parallax.com, I'm gonna switch that now to Cyberbot. And you'll see that now we have the Cyberbot products up, and that's on www.parallax.com. Then if you go to learn.parallax.com, what you'll end up seeing is if you're looking by hardware, you'll see the different products that are supported. Like here is the Cyberbot, a link to it if you're thinking about it from the hardware standpoint. And these are all the tutorials that are currently available for the Cyberbot. And then also another look at learn.parallax.com coming in from the start. You've got your Educator Resources, and so there's Cyberbot resources. And it's not all posted yet, but we will have, this is growing daily. And so we will have essentially an equivalent set of lessons for the What's a Microcontroller kit. Then I'm going to close as much of this as I can because my computer's been nagging me about resources. And then take a look at the circuit simulation stuff. So there are a couple of examples I wanted to talk to you about. I think we saw something very similar to this on Monday. So first of all, though, let's look at Tinkercad, because quite a number of you expressed interest in Tinkercad. Ken really likes it.
Awesome.
And yeah, I agree. And so, so what I did in Tinkercad just to try it out was I basically took it as far as I could. I hope it's loading. Very much hope it's loading right now. Because there we are, it was loading. Okay, meanwhile, I'm frantically shutting down other tabs and windows. Okay, so here we are with something that's kind of close to what you're working with. And you can basically go and pick out an LED and a resistor and place it and virtually connect them to the breadboard. And then you can start the sim. Oh, I'm sorry. You can also add code.
You're skipping over a really big thing here for those of us that are really into Tinkercad circuits, which is where did you get that object? Since it's not just a microbit.
Oh, let me try to remember. I think that's the drop down here.
Yeah, you go to all.
And I think it's probably circuit. Let's see if I got it in Microbit.
It's called
okay, right here.
Oh yeah, the Microbit breadboard. Got it.
Microbit breakout. So I basically went to Microbit.
No, I got it. It's new. I haven't logged on in a few months. That's awesome.
Okay. Okay, excellent.
Wow.
And so I placed that, and then for the code, although it is Python, it's the make code Microsoft version of Python. It is not the Microbit Foundation's version of Python. So there's a little bit of porting that would have to occur here in order to get the in order to basically get your code that you make physically work on a Microbit system to work on this. And that's probably okay. I can certainly show instructions of how to get familiar with the syntax of this. The thing that I'm I'm a little bit concerned about here. So let's stop and restart the simulation. I want to see a blinking light here. There we go. It's on. And there it's off. Okay. Oh yeah, that's yeah, so I don't know exactly why it's not. Oh, there it actually is blinking. You can see the little indicator that says it's on. And then it is kind of faint, but the green color does change when it turns on and off. So here we are. We've done a virtual breadboard. We've connected a breakout, and we've used some code that's similar to what's in the Microbit. The thing that I'm concerned about here is that we have quite a number of lessons. This is leading up to a question, by the way. So if we go to the Learn site again, and then into what's a microcontroller, and then taking a look at, say, electrical measurements, and maybe a current measurement or an Ohm's law type of thing where we're measuring voltage and then knowing resistance and calculating current. These are things that use calculations. And so you're going to do some calculations, maybe with a pencil, paper, and calculator, and then test it out on a real system after doing the calculation. Well, when we get to here, there's no support for that. I mean, I guess we do see a total current right here. I wonder if I can put this meter in.
There's a multimeter.
Okay.
That's a power supply. You can just go.
Stop simulation. Yeah, I'm so glad we're having this discussion. Okay, so
Press the code button to bring the tools menu back up.
Thank you.
You're welcome.
I'm new to this, by the way. All right, so then.
This was March 2020 through now for me.
Oh, wow. Okay. So to get to the meter, is this components all?
Yeah, or just type
Search
under
for it.
search,
Type
just
it in the
type
search string.
MULT. There you go.
Beautiful. Okay, so we actually can measure some stuff with this. All right, so that makes a huge difference. Now I can probably move forward with this. And is this the kind of thing that you guys would like to see incorporated? I mean, for me and for my education in electronics, there was coding, there was circuits and circuit theory. Then we usually had to design something and calculate what was going on, then simulate it, which is this part, and then build it and test it.
That's how I teach.
Okay, and that's
before they're allowed to go and plug things in backwards and burn up TMP36 sensors and LCD screens. I have them go and build all those, and I built that example I gave you of the ARDX, that PDF that had what to do and stuff. I built all of those, simulated those, have the code. They can go through, test, run that way, see it, make sure that it works, and then they've got their own built reference back to which they can refer. So yeah, that's spectacular. It's a shame that it's a slightly different change on Python.
Yep. I will definitely try to soften that blow as much as possible.
But this is awesome.
Okay. Okay, good. I think I can move forward with that. Looking at the other one. So this is my alma mater's version of it. They didn't tell me exactly what, but they said that they did notice some issues that they, yeah, Alan is the man. I'm looking at the chats. Thank you, Alan. And so here is an example that is more schematic oriented. And I did a similar file, or I did a similar setup that I'll show you. And I just kind of want to get your impression, because my overall goal was to try to get students comfortable with the material to the point where they were thinking more in schematic terms. And so here is an example where basically instead of the microbit, we're just adding and configuring a little voltage source. And you can go in there and say, I want a square wave with 75% duty cycle and that kind of stuff. That there is a few hard things that are hard for me to explain in a tutorial, like basically this device is sending signals that go equally above and below 0 volts. And so we have to add this 1.65 DC offset to get it to work right. And that's something that really bugged me. But overall, this seemed like a nice free resource. And you can, for example, view in the oscilloscope different nodes in the circuit and take a look at what their voltage is, what their current is. So like there's 1.5 volts between the resistor and the LED, and then over here it goes from it even shows, if you can see right here, it shows the current. There's the voltage, and then I swear I saw that. There we go. There's the current. There's a current trace, so 6.8 milliamps right there. And then there's also a voltage trace. And so this is the kind of thing that I envisioned using later on in the series. And so I'd like to get your thoughts about if there's a place for it, or if we really just want to only do Tinkercad, for example.
What's the link to that to mess with? I think both are important, personally.
I feel the same way. I want to make sure that there's consensus, though, before I run off and do whatever I darn well feel like.
I really, as much as I love all of your diagrams and everything you've done, I also, with one of the units that I teach, they pretty much get the schematic and they have to really manage the schematic as well. So, you know,
yeah, I mean, that's where I'd like them to end up. Oh, by the way, I pasted it in. This is cclearn.csus.edu. So that is my alma mater's version. The original I'm going to paste into, which is the Falstad site. And I can send you that little simulation file that I did. So here is the Falstad site. I went in already and I configured it to be a white background instead of a black background. So if it looks all black background for you, that's the default. And so I just pasted in the Falstad site as well. So this is the original, and then this one is the CSUS adjusted version with the file that I wrote, and it's really just a text file. So let me see if I can maybe paste the text in. See how much text there is. Oh shoot, I didn't do that right. Yeah, I think I'd better just send you the file for this afterwards, so you can play with it. So that's a follow-up item for me. All right, so yes, I'm seeing that there's a need for math. Oh, good point, that it'll increase SAT, ACTs. Oh, I was not aware about Falstad's other reputation. And so this is a, Delpher, would you be willing to talk about this briefly? Well, sound wave propagation is what this is. And so apparently he's done more than just electronics, that he's gone well into the physics area. That is pretty neat. Thank you for sharing the link. And okay, so let's see, what else? Is there anything, I missed most of the chats while presenting. Is there anything that you would, I'm hoping folks will unmute themselves and put in your 2 cents.
My 2 cents, Andy. This is Deborah.
Hello, Deborah.
Hi. My 2 cents, as I told you, my background is really software engineering, and so we did more of the logic diagrams, the and NAND gates, different gates, that's how it's like in computer science. I don't know if other people have, but so I was wondering if there is something that goes from those logic diagrams to the schematic, and then like the way you have the schematic here to the breadboarding, the actual building.
That is actually something I have on the list for going to the tail end of it. The way it works, the way it works or will work with this particular kit is I'm scrambling to try to get to the planned contents here, and I won't be. I'm going to have to add this to the list of documents to spruce and share, because this was an internal document that I did not fully set up contents. I'm searching my drive. I'm going to close these guys because I think they're taking a lot of resources. Almost there.
Well, while you're getting there, Andy, I want to ask everybody for prayer, because I am going back to the airport in a half an hour to pick my wife back up again. So,
goodness gracious, we will hold a thought for you. Where are you? You're not in Chicago right now, then?
I'm in the south side of Chicago, which is called Crete, Illinois. I'm actually on State Street, which goes all the way through Chicago. And it takes about 3 hours, took me 3 hours to get home from O'Hare. So that's on the northwest side. So Chicago is the worst place to drive.
That's where Leroy Brown lives.
That's right, in the
Outside of
baddest part of
Chicago.
town. Yeah, that's up the street in Ford Heights. Yeah. So
Wow.
that's like 2 towns over. So we lock the doors at night, but it's okay. It's all right.
Yeah, I used to live in Milwaukee and would apparently or would periodically go down to visit cousins in Chicago. It's a great place. Museum of Science and Industry is one of the coolest things ever made.
I love that place.
Yeah, me too. I can't wait to go back. All right, so so this is the overarching plan. And
Well, Andy, you can stay at my house.
thank you. I'll keep that in mind. We have in-laws there.
Oh, cool.
So they're at a they're in a high rise in the middle of town, and
oh, nice.
Yeah, so they but we have not. I mean, they recently moved, and then we've been busy, and they've been busy, so we've never actually connected up. Okay, so here is the logic part near the tail end. Then I stuck simulation at the end, but I kind of want to salt it in with the existing material, because that's pretty easy to do. We can just add another activity. But yeah, we have, for example, plans for an amplifier. And then for logic, the thing I wanted to do was use the microbits buttons actually, and or sometimes the buttons that you build on the breadboard, and then try to display the logic symbol that's going on the LED display. Because what you can do is, depending on the combination of buttons that you press, you can get an output that is the result of a not or an and or an or operation. And so those kind of things could also be done in the Falstad simulator, so that they could see a real electrical engineering take on it. How's that sound?
Cool.
It's cool.
And do
but
you mean you're going to take, Andy, do you mean you're going to take the AND gate and you're going to make it out of transistors?
No, I mean, we're going to code it.
Oh,
Basically,
because you could do that too. You could actually you could actually get a schematic for an AND gate and make it out of an actual transistor so that people see
And we
how
do,
the switching works.
yeah, we do have transistors in the kit, and by default, we are definitely making a NOT gate. And yeah, so we'll be using a transistor mainly to give some extra oomph to current when you want to make the light go on or something like that. But yeah, we can use the transistors also for basic gate logic. However, I would not do that first. I would do advanced transistors down here.
Yeah.
So, all right. How do you feel about that, Delphra?
Deborah.
Oh, it was Deborah that said, okay, sorry.
Yeah.
Getting everybody mixed up.
You see, what happens is that in high school, they meet these truth tables, and they meet it both in algebra, is it algebra? And they meet it in computer science. They meet these truth tables early on, right? So they're familiar with this. And then my take is that it would be nice for them to actually build the circuit. So this is why I was wondering, when they see this type of thing, the logic gate, if it could then go into simulation of like a circuit, even if they don't build it, the simulation could, do the.
Well, you see, they can build it though. I mean, the beauty is that with push buttons and a microbit, you can program the microbit to be an AND gate or an OR gate. It's not, the 7400 logic gates that we use, but it is, it is a way to actually experience the gates in a digital logic way. And then, yes, going back to the Falstad site, he's got logic stuff. Where is it? There we go. So, we can, oh, here we are with the logic gates. So we can definitely set up a simulation. We can definitely do a hands-on, basically calculate, simulate, and then build and test is all on the board.
That sounds great. And this, you're gonna send us this link, right? Or
yeah, so I pasted this in the link to the site, and I can send a group of links, because I also want you to have a version of this that I update when each time something else becomes reviewable, and then again when it's posted. And I would request, if you don't want to hear from me when something new is posted, go ahead and just email me that you want to opt out of that list. And also, if you would prefer to only receive emails through either your school or your personal account, let me know that too. And then I'll update the list accordingly, and then I'll be sending out announcements. And then if also we have a separate list that's going to be for pre-reviewers who want to look at the draft material. Okay, so.
Mr. Lindsay?
Yes.
So with the logic gate, I would be interested in that development as one of the things I do for my PLC class. Is I teach at a community college, and facilities maintenance is one of the departments that I teach in. And to be able to visually see how a logic gate operates, either doing the push buttons or whatnot, would be, I think, very beneficial. I've been trying to piece together that visualization for my students, because it's an amorphous thing. One of the old ways would be making the students build the gates using relays, as that was done originally in industry.
Yes.
And then show them, look, yeah, we could do it hardwire using the relays, or would you rather do it as a software and just program in? And oh, if you need to change something, you just have to change a few lines instead of going out to the plant, pulling out the relays and rewiring an entire panel.
Yeah, depending on your time situation, another way to do that might be to introduce it at a higher level and basically have just an example where the students can gather around and see the relays doing their thing. It just depends on whether what your time situation is and to what extent you think they're going to run into relays as logic gates out in the industry, if there's any stuff that's still in use that way. You know, to me, most of it is drifting towards computer control and solid state relays.
Oh yeah. And I'm going to duck out. I need to check where the source of smoke is.
Oh, okay. Good luck. All right, so back to the slideshow. I think that pretty much covers it for today. We had some optional products, but we're already, or projects, but we're already 15 minutes outside of the time. So I can go ahead and share links with you. We have a full list of your comments in the chat. And then, of course, I was also taking notes as we go. For example, before this session started, these are my follow-ups. Those being, want to try to implement continuous tone for the continuity tester. Somebody brought up that I made an incorrect KVL calculation. There was a request and overwhelming agreement to salt in troubleshooting in between various activities in order to build the students' skills. Unfortunately, that complaint about, I lost that one. So if you end up not seeing your request in our final product, please let us know.
Is it possible, Andy, that complaint about is also tied to equation to inline text? Did it just maybe at?
Oh, thank you,
That's what
Alan.
our conversation was, yes,
Yeah,
Wednesday.
because I remember our conversation, and I think that's
Totally, that was it. I felt really bad because I'm like, oh no, I lost one. That's it. Thank you. All right.
One too many bullets.
Yeah. and then I loved the suggestions you made for assigning a name to a pin object and then using that. That is just so cool. Very much looking forward to adding that. So there'll, wherever possible, I'm going to make MP4 links available so that any of the animated GIFs, if you're trying to use it as a teaching item, you can play and pause it. I think that's really important. There were a number of spots going into this where we just had the GIF. Alan, I think you mentioned the railroad crossing for alternately blinking LEDs. I'm definitely adding that in. And then Ed, you asked for constants to be high and low. And of course, these are things that also I noticed that most teachers were, most of you teachers were saying, yeah, that's a good thing. So so those are the ones I recorded through Wednesday. In order to allow my computer to not freeze up today, I had to close everything. So my notes are currently closed because I've been getting resource usage warnings. But this is an example of things that we got from you and that we're taking and going back and updating our materials accordingly. And with that.
Thank you, Andy, for
another
awesome
correction.
workshop.
Oh, I'm sorry, another correction?
Yeah, I put it in the chat, but the chat goes by pretty quickly. I was building and messing around with the potentiometer in the servo. And you've got a GIF anim that shows the connection in a location that's, well, slightly different than what I'll call this all-in-all board. So I just moved it, but you've got the potentiometer connected to pin 10.
Yeah, so that hasn't been updated yet.
Okay, but in the code, it's pin 4, which I was able to catch, but
Yes, okay, so I don't need to, well, I'll write it down anyway for closure. But yes, that one is essentially servos and then potentiometer and potentiometer controlled servo and onwards. So yes, I started with it on P10 and I'm switching over to P4, although there will be one that's probably on an out of the way IO pin where we measure RC decay.
yeah.
Also,
I created a jumper wire to make it go from where the potentiometer is next to the two buttons because the resistor just won't quite stretch.
Yeah,
It's close. But
yeah. Well, that's another thing. I might just leave it there and show them how to yank, you know, to adjust the circuit so there's a capacitor in there so they can do the decay with the same potentiometer in the same spot. Have to be careful about that because then if they go back and try an activity that's using it as a purely analog device, it might run into some trouble. I'll take a look at that.
so I recall on Monday, I guess it was, that we were discussing the possibility of rewriting some of your code so it doesn't include P0, which is the speaker, so you could use the speaker for other options.
Yes, so the issue is that we are trying to use the speaker at the same time we are trying to use, or when we use a speaker at the same time that we're trying to use the P0 probe. And I believe that's in there already. Let me make sure.
And is that using the internal speaker on the version 2?
Yeah, I made a mistake and didn't give that some thought. So basically that is part of the continuous tone for continuity tester item.
Yeah.
And so basically I'm going to be going in there and saying, okay, when am I going to be trying to use the speaker and P0 at the same time? Is there a trick I can use to do it code wise, or do I need to move to a different pin?
Is the limitation the microbit, or that Python is procedural, and so you can't kind of time slice in and say that if this is high, then also do that?
Well, and so basically for me, step one is to see about time slicing. There are some time slicing might cause you to get a warble out of it.
Yeah.
When it slices out of the speaker, or warble or a click when it slices out of the speaker and into the measurement. That might not be a big deal. But it might also mess with the circuit. And so another thing I have to do is look at what happens when you turn the speaker on and off. Is there a diode inside the microbit that protects the circuit, or would I be inadvertently modifying the circuit with the probe? If that's the case, the decision has to be between updating our documentation so that all the continuity testing happens on, say, P1 or P2, or yeah, it would be P1 and P2 instead of P0 and P2.
Those pins will be really close.
Well, I did manage to, well, let's take a look at how I did it, because I use P1 for the ohm meter. Here it is, measure resistance. All right. Okay, so this is how P1 is used with the ohm meter. A magnifying glass is coming up in a second. Oh no, I'm sorry. I think it's the one where we build the ohm meter. So going back a page to measure resistance. Okay, here we are. So this is the circuit right here. And so one clip goes there,
Got it.
and then the other clip would go underneath.
And in fact, I think it's a very bad idea to have the circuit with the 3 pins so close together. And I would suggest you've got all these little jumper wires, just jumper it up to the top so that there's plenty of space and there won't be any shorting out. Students that are unfamiliar with the use of these clips, they're going to short those two together all the time.
Okay, so you're saying possibly use a larger portion of this region right here?
No, further up, keep going up, 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 keep going up. There you go. All that empty area up there is plenty of space to just throw a jumper from P0 or P1 or P2 up to the top and then connect your red and do the same thing for the black, way away from anything that you'd otherwise be shorting out.
Great idea.
Yeah,
Okay.
I second that.
That one may take a while longer to implement because there's a lot of man hours involved in that particular one.
It'd still be a good use of the real estate up there.
Yeah.
I do agree. Yeah, okay. So place 3 pin headers.
Far, 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 far apart.
All the way on the top.
It's also a good learning tool. I mean, I think that the microbit will protect itself if those two touch, not if they stay crossed. But if somebody's saying, hey, I'm having a tough time getting my alligator clip to connect to that without touching, we can start talking, really going back to that definition of the breadboard. And how could we move this? How could we still use pin 0 and take advantage or something like that?
Yeah, okay.
And that takes right there, even though that's jumping over to a different row, you're going from 30 to 29, it's fine. But they could just slide that over the valley and jumper it.
Yeah, the number of person hours it's going to take to reshoot these video clips is pretty significant. So what I need to do is just let you know that that's not something you're necessarily going to see immediately. I mean, I heard you, and we're gonna do what we can to make that happen, but I don't know that. I'm sorry.
Piece of cardboard.
There were a couple of statements, something about a piece of cardboard and then another one.
I put a piece of cardboard between those two because even the first day when we were tooling around, I noticed they was getting really close. It was just easy to just put a piece of cardboard between the two, separate them.
Yeah, pulling the sleeve over as far as you can also is a good thing. The plastic sleeve that covers the alligator clip part. Then there was somebody else who chimed in, but we couldn't hear you. Could you come back and let us know your suggestion? All right. Let's see, or chat it to us either way. Okay, apparently, Ken posted that Microbit does not have any plans to use a switched battery. Whoa, Ken, I didn't know that. He also said that that if you want to power down the Microbit, you can hold the reset button for 5 seconds.
I'm going to try that right now.
That would be awesome. Now I'm trying to think if that gets us anywhere and what we actually, that would be if you have the battery connected to the microbit. But the problem with that is that the microbit is not designed to supply enough current to the servo.
Yeah,
And that's why we have that separate battery input. Regardless, I really love the idea of powering down the microbit like that. Thank you, Ken. Well, this has been probably as good of a learning experience for us as it has, as I hope it's been for you guys. And thank you so much for all your input.
But thank you for the
And thank
time
all-
you put into it.
Thank you. Have a good
yeah, thank
All
you
of you at,
guys.
Yes,
Power
thank you.
Ops and Cyber.
And
And thank you.
yeah, and I'll be sending follow-up emails, looking over this video to make sure I keep all my promises. If you see one that has not been kept, please do email me so I rectify that matter.
That 5-second thing
Thank you.
works.
The 5-second rule?
Yeah, it doesn't work for Cheetos, but it does work on the battery.
Oh, okay.
Just
Thanks,
saying.
Andy. Thanks very much. And remember, Old MacDonald had a computer, IEEE-IO.
Oh, that's good. I've never heard that one before. Nice.
Not many people get it, you know?
Well,
Yeah, thank you. This has been great. I mean, the way, there's just so many positive things about this that I just can't wait to keep going.
All righty. Well, you'll know as soon as new stuff comes up because you're on the early reviewers list now.
And we're all waiting for Alan to send us ears of corn.
And they were heavy, but I muted so I could eat it. My son cut it. And I mean, I would say, Nicole, you know, being from Iowa, what it's like to just get an ear of corn and eat it. But there's, you know, we